Remember, NQ in the sense we are adding a new item to the queue, that too by making use of this rear pointer. If rear is pointing to n-1, at that time queue will be full or overflow. If that is the case, we can't add any more element, so we have to exit and this if condition will going to be ended there itself. If I increment the friend by 1, then friend will come here. What it indirectly mean? Whatever we had in 0th position, that got deleted. Hello everybody, welcome back to the session 2 of chapter 3 on the unit 2 of B.Ca's second semester. Subject called data structures using C. As we all know that we are learning with the concept of queues data structures. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of my previous session. As we all discussed in the last session of this unit and chapter, we got to know regarding the queues. As I discussed earlier, this queue is a data structure, right? So that queue will going to have a ordered collection of elements, and insertion and deletion both will going to take place at a different end. So if you are inserting an element, that at the rear end, if I wanted to delete an element, that will be taking place at front end or a front pointer. And also we got to know regarding representation of a queues, that too by making use of a linear array or single dimensional array. And also I have discussed regarding the types of queues. So totally we have 4 types in a queues. We have a simple queue, circular queue, priority queue, and at last we have double-ended queue. And also I have discussed regarding the operations whatever can be performed on this queue. So in our today's session, we're going to learn about the operations which can be performed on a queues in depth manner. That means I will be discussing regarding NQ and DQ along with its algorithm. At last, we are going to learn about what are the application that we can have on the queue. We'll see the first topic, that is regarding operations on queue. Already we know all these operations can be done. You just have a blush up here. So queue mainly to create a new queue that will be empty. If I wanted to delete or if I wanted to insert an element, then there must be an existence of a queue. That is why we are having this queue operation. And next we have a NQ. Remember, NQ in the sense we are adding a new item to the queue, that too by making use of this rear pointer. And what if I wanted to delete or remove an element from the queue? From the front pointer, we are going to do this operation or a deletion, and we are checking whether the queue is empty or not. If we have element, then only we can delete. If I don't have any element or if the queue is empty, then we can't do the deletion, right? And if you are trying to add an element which already queue is full, then we are going to call that as a queue is overflow or queue is full. Full or overflow. If I am trying to add a new element, when the queue is full or queue memory is full, at that time queue is overflow. And if I am trying to delete an element when there is no element in the queue, then we can call that as a queue is empty or underflow. So these two conditions you have to remember, right? This is main thing you need to remember. Then at last we have a size, mainly to specify the total number of items whatever we have on a queue, then that can be given with the help of this size. We'll see the first type here. Here you can see the scenario. We have a queue called queue. The queue name is queue here and it has 5 elements. That means I'm creating a queue which is as of now it's empty, and we can add totally 5 elements of size 5. So now initially queue is empty. So what you have to observe now, when I'm creating a queue, at the time front pointer and rear pointer has to be located somewhere, right? So when that creation of a queue is taking place, at the time front will be indicating to -1. That means I don't have any of the element right now, but I have created a queue. So that front become -1 and rear pointer is also at -1. That means it is not at all initialized or it is not taking place anywhere in the creation of a queue. So as of now, when I am creating a queue, front and rear both will be -1. That indicates we are creating a queue. What is the next point here? If I wanted to add a one element called 8, I wanted to add a new element called 8 in the queue, then the front and rear indicators are set to 0. So initially it was not there in any of the location. Now I wanted to insert an element called 8 to the position or as a first element. At that time, both front and rear will going to be pointed to the first location. So here rear is equal to 0, front is equal to 0. From which end we are going to insert an element? From the rear end, right? So to this location, or you can see here, as of now the rear pointer is locating to 0's location. So the name of Q is Q and Q of 0 is equal to 8. So this 8 will going to be assigned to the 0th position of this Q. What if I wanted to insert one more element to this existing Q? So that is what I wanted to add 12 to the Q. At that time, then the rear indicator would be incremented by 1. So now, if I wanted to add an element, then that rear pointer should be incremented by 1. So previously it was in the location Q of 0. That means in the 0th location it was there. So now it is pointing to this Q of 1. So rear will going to be incremented by 1. It was 0. So now it is 1. But this front pointer is at 0. Why? Because I am performing this Q insertion or NQ. At this time we don't require this front. So this front pointer will be pointing to the 0th location itself. So wherever I wanted to delete an element, at that time that front pointer will be incremented. But now we are inserting an element to the Q, so that only rear pointer will going to be incremented by 1. When it reaches to the n-1, then we can say that Q is full. We'll see here. So Q of rear is equal to, what is the location of rear right now? That is the first location. So that for the location of first location, the element called 12 will going to be initialized. So in the Q of 1 position, the element 12 will going to be copied here. So we are left out with 3 more places. Same procedure will going to be repeated again and again until it reaches to the last location of a Q. So you can see here, we're going to repeat the same procedure for 3 more times. Why? Because I wanted to add 3 more elements. Let me consider that element as 4, 18 and 34. Right? So now front will be at the 0th location itself. So initially Q was at that rear pointer was at 0. By adding this 8, that will be incremented by 1. As of now rear pointer is at 1, and if I wanted to insert one more element called 4, then rear pointer will be incremented by 1. So rear will be at 2. If I wanted to insert one more element called 18, at that time rear will be incremented by 1. Again Q of 2 become Q of 3 rear pointer. And if I wanted to add one more element called 34, then rear pointer will be at this location. So now rear is equal to 4. Rear is at 4. So when it reaches to the last position, as we all know that we have created a Q which is of only 5 elements, but it is at the end of a 5th element. So the rear pointer is equal to, what is that? n-1, or it is at the position called 4. So what is the total number of elements? That is 5. So now n is equal to 5 when the rear is equal to n-1. That means 5 minus 1 will be 4. So rear is at location 4 now. So when rear is equal to n-1, then I can say that Q is full, or which is at the last position. We can't add one more element to the Q. Remember this one. When rear is equal to n-1, at that time we can say that Q is full. So we can't add any more elements. So front will be in the location 0, and now rear pointer is pointing to the last element of an array. This is how we are going to insert an element to the Q. That operation is considered as what? NQ. So here you can see the algorithm for the insertion. In order to do the insertion of an element with the help of this Q data structure, or we are inserting an element to the Q with the help of linear array data structure. Okay. So for that we are going to call that operation as a NQ, and if I wanted to insert an element To the queue, I require a queue. That means I need to create one queue. I require rear and front pointer, and we require an item which needs to be added. You can see here, queue is the array with n elements. That n can be any numbers. If I am giving the n as 6, then I can include 6 element into the queue. And front is a pointer that contains the location of the element which needs to be deleted. Wherever we wanted to delete an element, then front pointer will be there to indicate that, and we have a rear pointer that will going to contains the location of the element which needs to be inserted. So as of now we are doing this insertion. In order to do the insertion, I require an item. That is the item which needs to be inserted. We'll see the each step one by one right now. When it comes to the step 1, you all know the representation. So when I'm creating a queue, at that time, front and rear both will going to be pointed to -1, right? So when we are inserting a new element, at that time, this array rear pointer will be at the location 0. If I wanted to insert one more, 0 plus 1, to the next position, it will be incrementing. We'll see the first position. If rear is equal to n minus 1, that means we can say that n minus 1. So if the number of elements are 3, 3 minus 1 is 2. So if rear is at the second position, 0, 1, 2, right? No? So here rear is at the second position. If that is the case, then what we have to print? Queue is full or overflow. We are checking for the overflow condition here. If rear is pointing to n minus 1, at that time queue will be full or overflow. If that is the case, we can't add any more element. So we have to exit, and this if condition will going to be ended there itself. If this is not the case, if we have an element or if we have a space to add an element, if rear is not at the n minus 1 location, then what will going to happen? If front is equal to null, that means front, why we require? Initially it was -1. If I am inserting an any element or if I have any element within a queue, at that time front will be incremented by 1. That means it was -1. So now it becomes 0th position. So here when front is equal to null, check whether the queue is empty. So if that is the case, if don't we have any of the element, at the time both front and rear will be incremented to 0. So in this if condition, both front and rear pointer both will be pointing to 0th location. That means from here we can start adding new element, right? So this will going to take place only front is equal to null. That means when the front is indicating -1 or null, then only we have to consider that queue is empty. At that time we are going to increment the front and rear pointer both by 0, or we initializing the front and rear pointer by 0th location. Or if front is not indicating to null, or if it is specifying any of a location in the queue, at that time we can able to add it. That means rear is equal to rear plus 1. So you just imagine I have a queue here. Let me write it again. Okay. So now 0, 1, 2, 3. So now let me consider 10, 20. So now rear is at this location, front is at this location. Fine. So now front is equal to null. That means here front is not equal to null. So if the if condition become false, then it has to execute the else pointer, right? So it will comes to the else part. What we have in a else? Rear is equal to rear plus 1. So rear is in the location 1. Rear plus 1 in the sense rear will be incremented by 1. So the location of rear is now at the second position of a queue. So when it comes to this one, this rear pointer will going to be incremented by 1. So now I can add an element. Queue of rear is equal to item. For the rear, from the rear pointer, we can add an item to the queue of rear. So queue of rear in the sense what? Let me consider the queue as queue name as queue itself, and rear pointer is at the location 2, and I wanted to add an element called 30. So this 30 will going to be copied to the location queue of 2. Fine. So if I am done with insertion or NQ operation, then it will going to exit or return to the main function. Again, if I wanted to add an element, then I will come here. Whether the rear is pointing to the n-1 or to the last element. Is it pointing to the last element? No, right? This part is not going to take place. That means Q is not full. So it will come to the next step. So front is equal to null. Is front is pointing to null here? No, because it has some elements. So if that is the case, if this condition become false, again else part will going to execute. So in this, rear is equal to rear plus 1. So now rear was in the second position. It will be incremented by 1 now. So 2 plus 1 become the 3. That means the Q or rear pointer will be going to be incremented to next position. So it will be pointing here, and now I will assign the value called 40 here, so that this position Q of R in the sense the location 3 now, the third 40 will be copied to the location 3. So now I can add an element 40 to the location 3. That means now where we have rear is equal to n-1. Again, if I am trying to add a new element, then it will comes to the first step as well. Rear is equal to n-1. So n in the sense number of elements are 4. 4 minus 1 is 3 now. R is equal to 4 minus 1. That means R is indicating to the location 3. That means that is the last element. If that is the case, then it will going to show that Q is full or overflow. So that indicates we can't add one more element to the Q. Why? Because Q is completely full. That condition is considered as what? Overflow or Q is full. Fine. This is how we are going to insert an element to the Q. First, I need to check whether this Q is full or not. So, if not, then I will check whether if the Q is empty. So, if that is empty, both front and rear pointer will be initialized to 0. Then, rear pointer will be incremented by 1 in order to add a new element to the Q. Fine. This is regarding algorithm for insertion, and this is also very important topic. Write an algorithm to insert an element to the Q data structure. Fine. Next, we'll see about the DEQUEE. So, till now we have learned regarding how we are going to insert an element. What if we wanted to delete an element? Now we need to bother about the variable called friend. So, here also you consider a Q. The Q name is Q itself with 3 elements. I have 3 elements. When I am declaring it or when we are creating this Q, totally it has 5 elements. As of now, we have only 3 elements in it. And I wanted to delete an element called 8. So, where do we have this 8? That is at the location 0, right? Then the value of friend will be incremented by 1. So, initially friend was at 0 and rear was at the position 2. So, you can see here, for the insertion, rear will be at 0, rear will be at second position and front is at the 0th position. So, when we have this front element is 0, that indicating the first element. If I wanted to delete this end, if I increment the front by 1, then front will come here. What it indirectly mean? Whatever we had in 0th position, that got deleted. If I am incrementing the front pointer by 1, the previous element will going to be deleted as well. So, if this front pointer is incremented by 1, then deletions are done from this front pointer. So, that as of now, rear will going to be point to this Q of 2 and front is in the location 1. What if I wanted to delete one more element? That you can see here. I wanted to delete an element called 12, which was in the location Q of 1. So, then the value of front will be incremented by 1. So, if I increment the front pointer from 0 to 1, the first element will going to get deleted. If I increment the front pointer by 1, again, it will be in the Q of 1. If I increment it, this location element is also going to be deleted. So, as of now, rear is pointing to this Q of 2 and also this front pointer is also pointing to the Q of 2. That means I have only one element. You can observe that when this front and both rear elements are pointing to the same location, then we can say that we have only one element. So here you can observe that Q has only one element when both friend and rare both are equal or both are pointing to the same location. At that time, we can say that we have only one element. Why? Because if I wanted to have this Q of 2, you can see here, rare and friend both are pointing to the same object. That indicates that we have only one element in the Q. So here Q has only one element. If you wanted to delete this element, then the Q of Q becomes empty. So now the friend pointer will be incremented by 1. This element is also going to be get deleted. So that set the friend and rare pointer to -1. If you don't have any of the element, both friend and rare pointer will be initialized to -1. Okay, at that time we can say that Q is empty. So if I delete all the elements from this Q, at that time the Q, rare and rend both pointer will be indicating to -1. At that time it will be minus or it will be empty. So remember one thing, when friend and rare both pointers are indicating to the same location, we have only one element in the Q. And if both friend and rare are indicating to -1, at that time Q is empty. And if rare pointer is pointing to n-1, then we can say that Q is full. So these three scenarios you have to be very conscious, and this is important. Friend is equal to rare, only one element. Friend and rare both are pointing to -1, the Q is empty, and rare pointing to n-1, that is Q is full. It's all regarding DQ or deletion of an element from the Q. So now we'll see how this will going to work along with the algorithm. We'll see now. That is what? An algorithm for deletion. That means deleting an element from the Q. So you consider here the function name as DQ. If I wanted to delete, what and all I require? I require a Q and I require a friend and rare end along with a item. So now here Q is the array with n elements. That n elements can be any number. So if I am giving a n as 6, at the time we can have only 6 elements in the Q. And friend is the pointer that contains the location of the element which needs to be deleted. So now we are doing this deletion. So our concern is all regarding this friend pointer right now. And also we have a rare that specifies the location of an element which we are going to insert, and we have an item that is an item which needs to be deleted. Fine. We'll see each step one by one right now when it comes to the step 1. So before that, let me write the Q. That is empty Q. Okay. Let me consider the Q name as Q itself, Q of 0 and Q of 1, and I have Q of 2, right? So as of now, friend and rare both are at -1. That means I don't have any element in the Q. We are just simply creating a Q. So now, friend is equal to null. So if friend pointer is pointing to null, at the time we can say that the Q is empty or underflow if you don't have any element. So if friend pointer is pointing to -1, that is to the null, at the time clearly you can see that we don't have any element. That condition what we can say that as Q is empty or underflow. So if that is the case, we can't delete anything from the Q. So we have to exit and end of if will going to takes place. Or else, what if I have an element? You just imagine I have 10 and 20. So here rare pointer will be here, friend pointer will be at the 0th location. So as of now, friend is equal to 0, our rare pointer is equal to the location 1. This is what the rare and friend pointer location as of now. So, if this is not the case, if friend is not equal to null, or if it is in any other location than the null, then Q of friend is equal to item. So, this Q of friend, where do we have friend now? That is 0. So, Q of 0. So, now friend location is at 0th position of Q. What is the item that we have there? That is 10. So now I wanted to delete an element called 10 which is at the location Q of 0. Fine. At that time, if friend is equal to rare, we have one more scenario here. If both friend and rare both are pointing to the same location, then we can say that that has only one element. So here in this scenario, friend is not equal to rare. Why? Because friend is at the location 0 and rare is at the location 1. This is not in the same location. So that condition will not going to be satisfied. So this condition become false. So as of now, you just imagine if this is the case, or if both and friend both are pointing to the same location. So here let me consider 0, 1, here 10 and 20, this is friend, this is rare. Both are pointing to 0th location. If this is the case, at that time friend is equal to null, rare is equal to null. I have only one element and that needs to be deleted from the queue. So if that is the case, both friend and rare pointer both will going to be set to the null or to the -1. But as of this scenario, now friend is not equal to null. So if this is not true, then it comes to the else part. When it comes to the else part, here friend is equal to friend plus 1. Friend was in the 0th location. So now friend plus 1 in the sense friend pointer will be comes to first position. So now how it will be? So we had 10, 20. So now friend and rare both are pointing to the same location right now. Then what happened to this 10? If I am incrementing the friend pointer by 1, then that directly specifies that we have deleted an element which was at the friend location. So now the 10 got deleted from this location. So if it does so, then that friend pointer will be incremented by 1. We have deleted an element, then it will return to the main function. If this is the case, if I wanted to delete one more, let me go with the algorithm again. Friend is equal to null. Is friend pointer is pointing to null here? You consider this scenario right now. I have 0, 1 and 2. These are my location of a queue called queue, and here you can see that friend is not equal to null. That means friend is in the location 1. So this will not going to work. That means the queue is not empty. Then it will come for a next location. Item is equal to queue of friend. Wherever the friend pointer is there. So it is in the pointer 1, right? It is in the location 1. So that value, whatever we have in queue of 1 will be copied. So that 20 is in the location queue of 1 right now. Next it will come here. If friend is equal to rare, if friend and rare is equal to same, yes, right? That indicates we have only one element in the queue. That is what? 20. If that is true, friend is equal to null, rare is equal to null. So what we are doing here? Friend will be initialized to -1 and rare will be initialized to -1. That indicates both friend and rare pointer will be initialized to null or to the -1 location. If we do so, this element is going to be deleted. So now whatever the element that we had in a queue, that was 20, that got deleted from the queue. So if portion will going to work, then no need to come for else part, then we are going to return. So again I will come here, friend is equal to null. Is it? Yes, because we don't have any element. In my next scenario, how it will be? Then 0, 1, 2. Queue name is queue. Here I don't have any element. So here friend is equal to null, that is -1. Then it will going to show that queue is empty or underflow. This is how we are going to do the deletion of an element from the queue of linear array. I hope you all understood. Let me move to the next concept, applications on queues. So here I have listed out where and all can we use this queue data structure. It can be used in the simulation, and also we have various features of operating system in order to schedule or in order to have a queue. That means if I wanted to play some music, there also we have a queue concept. If I wanted to play the videos one by one in the YouTube, there also we can make a queue. So there also we can have this operating system features. In order to incorporate some of the feature of this OS or operating system, then there is a possibility of having this queue data structure, and also multi-programming platform system. In that multi-programming, or if I wanted to work based on some priority, then priority queue can be used there, and for different types of scheduling algorithm. So if I wanted to give some priority, or if I wanted to have it in a circular motion, or wherever we wanted to delete or insert, so there also you can have the scheduling algorithm. In order to do this scheduling algorithm, we can have this queue data structure and round robin technique algorithm. Along with that, printer server routines based on some priority. Most of the priority queue operations or priority queue data structure will be used in all these scenarios. Along with that, we can have certain application software that is also based on the queue data structure. So these are the different kind of fields wherever we can have a data structure called queue in order to help all these application field. I hope you all understood. It's all about our unit 2. Let me meet you in the unit 3 in my coming session. Until that, keep learning, keep on growing. Thank you.